So, hello guys. Again, this class is a continuation of the last class, and in last class we have finally we have come to the conclusion with the equation of motion regarding acceleration, the first equation of motion. And today we are going to do more two equations of motions. This chapter is basically based on that equation of motion, and let us see how far we can go today. Please ignore the background noises because it's like raining right now. So we were at kinematics, and we have seen that when something moves, so if we have a graph like this and you have x versus t, that means the time is the x, that means the distance is increasing with respect to time. That means there is some velocity, that means there is a rate of change of time, change of displacement with respect to time. Also, you have seen that the velocity can be considered as the gradient of the curve. That means v is nothing but your tan theta also. So by looking at the graph directly, we can always estimate the velocity. So if some where the graph is like blunt and somewhere it is stiffer, so we can say that in this one v2 is much larger than v1. Okay. And basically we also have seen that if we have a graph like this, your x versus t, and which is not linear, rather it's like this, that means my theta is changing everywhere, and as the theta is changing, that means v is not constant, v is also changing, right? So when v also changes and v increases, the rate of change of v is called your acceleration, right? And we have seen that rate of change of v is nothing but the final velocity minus your initial velocity by the time interval. And from that we have come to that one, that v equal to u plus at, where v is my final velocity, u is my initial velocity. By this equation you can get it. One more thing to revise, that is, if you have a v versus t graph and you have linear, that means acceleration is there, and acceleration is uniform. That means as the theta is here same, so we can tell that delta v by delta t, which is our acceleration, is also tan theta in this case, and as theta is same, so a is also constant. But in case when your this graph is not linear, rather like this, that means theta is changing everywhere. So as the theta is changing everywhere, that means a is not constant in this case. So if you have a graph like this, it is called increasing acceleration. If you have a graph like this linear, that is called uniform acceleration. If you have a graph like this, that is a decreasing acceleration. Okay. And something is also called retardation. Whenever you will see a slope like this, like a graph like this, where the slope is negative, that means my theta is in the down part from my horizontal line. So in that case, tan theta value will be negative, as well as our acceleration will be negative. That means acceleration will be treated as my deceleration or retardation. One more thing is there, whenever you are asked to find the distance covered by any object within some time, say from 0 to this point, that is my 5 minute. So what you have to do, you have to just find out the the area under the curve. That's it. Okay, so it is only in v versus t graph. Now coming to our next line. Now before we go for our next equation of motion, something I must tell you. You must be remembering that you must recall that v equal to u plus at is only allowed when acceleration is there, and s equal to, or better say x equal to vt is allowed only when there is no acceleration. So these equations are used in different cases. Now let's say you have a scenario where your velocity is changing like this. So this is my v and this is my t, and you can see clearly that velocity is increasing. That means there is acceleration, right? So if for the same scenario I draw another graph showing x versus t, so I will see that the velocity is increasing. That means the graph will be like this. So these two are the same scenario, but the graph is drawn, or the plot is drawn based on different captions. Now if I say that I want to calculate the the final distance, or I want to predict the motion from this point to that point, and I can easily see here कि I cannot use this formula x equal to vt. Why? Because at every point of time my velocity is changing. So which velocity I am going to put here? So to solve this problem, to deal with this problem, what we are going to do, we are going to take one new concept of average velocity. So your average velocity is something that we have to bring here in order to calculate the predictive velocity, or the final velocity for one motion having acceleration. Now what is average velocity? The average velocity is given by the total distance covered, or the total displacement covered, by the total time taken. Total time taken. Now see here. Now you will say, "Arey, what is new about this thing?" Let's say I am considering a simple scenario where one object, say A is my one object, and it is going to B, but with two different velocities. First, L1 distance it has covered with velocity v1, and the next L2 distance it has covered with velocity v2. So in that case you can see that my total distance covered is L1 plus L2, right? And my time taken here and here is different. So the first one, I know that if this whole section from here to here there is no acceleration, it has gone in a constant velocity v1, I am assuming here, then I can use that formula, that is L1 equal to v1t, right? So t will be my L1 by v1. Also this will be my t1, and my t2 will be similarly my L2 by v2. So my v average will be L1 plus L2. Just a minute. So L1 plus L2 by T1 plus T2. So if I put the values here, I will see that my V average will be L1 plus L2 by this one, that is L1 by V1 plus L2 by V2. Now, so these are the method of finding V average. But when you have uniform motion, okay, so in case of uniform motion, uniform acceleration, basically you will see that this time taken and that time taken are almost same. That means what was my general formula? So this is my general formula, okay, but whenever I am finding V average for some scenario where my T1 and T2 is same. So let's say this is the case where my T1 is equal to my T2. So in this case, what is going to happen? Let us see. So the scenario is that your let's say from here to somewhere it is going, and the whatever is the distance covered and whatever is the speed, but the time taken for both of the section is same. In that case, what happened? In that case, if this is V1 and this is V2, so in that case already I have told you this is the formula we are going to equate. So my V average I can write, instead of T1 T2, I can write L1 plus L2 by 2T, right? That why? Because my T1 equal to T2 equal to T for some special cases where there is uniform acceleration. Now in that case my delta A means the change of A with change of time is 0, or you can rather say my acceleration is constant. The best way to tell is that my acceleration is constant. So if my acceleration is constant, so in that case what I can write that the time taken for the both cases are same. Okay, we will come back to it, why it is so. Now if I split this, I can always write L1 by T plus L2 by T, and half I am writing at the last. Now you can see that L1 by T, that will be my V1, right? So V average will be my V1 plus this is my V2, because L2 by T is my V2, and then half was there at last, so this will be half. So this is basically the formula of V average when your time taken for both the part will be same. But whenever you will be having some problems like numericals, and it is mentioned that this much it has gone in that time, and this much it has gone with this velocity, and that much it has gone with that velocity, you must apply this formula only. So this formula is basically the general formula, okay. Now this formula, whatever we are doing right now, this is the special case for uniform acceleration. So if you see the graph of uniform acceleration, you will see that this is like that. Why? Because my theta is same. Why theta is important here? Because this part will be my delta V, this part will be my delta T, and if that means my tan theta is in this case delta V by delta T, which is nothing but my acceleration, I know, and my theta is same everywhere. That means my this A is also constant everywhere. So in same interval of time, the increase of the increase of velocity will be same, right? Because it's uniform. So from here to here, let's say in this 5 minutes, whatever will be the increase of velocity, in the next 5 minutes the increase will be same. That means if it has gone from 10 to 20, then in that case it will be from 20 to 30. That means it's going linearly. So in that case only we can apply this formula. Now in this kind of scenario, why we need it, right? Why we need it? Because now when we are trying to predict what will be my total distance covered after some time, okay, whatever time that, so I will decide. Let's say I want to know if something is moving with velocity like with variable velocity, that means with constant acceleration. So let's say, so let us say one object is moving with a acceleration. Okay, initial velocity was u and final one is v. Okay, so I want to know what is the distance after time t. So we have to find the distance after time t. So distance covered after time t. So this we are going to find out. Okay, now we know only one formula, that is x equal to vt, but this formula is only for the cases when there is no acceleration. But if acceleration is there, obviously we have to take the average value. Now you will ask me why. I told you already, for v versus t graph, if you want to know the displacement at a certain time, the displacement will be the area covered by the graph, right? Area covered under the graph. You can easily see if my initial velocity is 0 even, and for simplicity I am taking this, and let's say at time t I want to find out the velocity here, which is v, say. So basically the area of this triangle will be my half into base into height, that is my v, right? Now in this case you can easily see that this is the case when we have 0, but in case you don't have 0, rather than you have something like this. Let me draw nicely so that okay, so this is my axis, these are my axes. Oh, so these are my axes, and this is my the graph, this is my v, this is my t, and I want to know what will be the velocity distance cover from this time to that time. Okay, now so you can easily see one thing. In that case it is going from u to v. So this is initial is u and the final is v, and this v is the general axis level. This t is general axis level, and this so that means this is my triangle I am considering. So that one is my v minus u, and that is my delta t, or I can say that the delta t is my t. Okay, so this is my t, that means t1 minus t2 is t. I have taken this as t for simplicity. Now what will be the relationship here, what will be the area under this certain portion of curve? We can easily see one thing, this area we have to find out. Now if you talk about this area, particularly this area, if you want to find out it geometrically, we can do one thing. That is, the first one is my half, then into v minus u into t, right? And the downside is my 0 to u, that is my u into t, so plus ut. If you just do a little bit of interaction, like a little bit of simplification here, you will get v by 2 minus u by 2 plus u, and t is there. So basically, if we just calculate this, so ut minus ut by 2, so that means 1 minus half, that will be plus. So instead of this complicated figure, I can just write here plus u by 2, and I can just remove it if we do the calculation. So finally, one thing you can see, we are getting this thing, that is my x is equal to my v plus u by 2 into t, and this thing is the same thing why I am taking v average t, because already we have got v average is v1 plus v2 by 2. So in both way we can find this like stuff. Now we already know that v equal to u plus at. That is my first, that was my first equation of motion, and this time I am going to use this here. So basically, see, x I want to know, v, that is the final velocity. I don't know the final velocity. When the motion is started, do you know what will be the final velocity? You have to find it, like you have to calculate it. But what you know, that just like when the motion is started, you know at what time it is started, what was the initial velocity, and from where it has started. Other than you don't know anything else. You can measure acceleration by the rate of change of velocity, but other than nothing you can know about it. You have to calculate. So that means my v is unknown here, and I want to exchange the v with these known factors. So instead of this v, if I put here this value, so I will be having u plus at plus u by 2 into t. So finally I am getting 2u plus at and then t by 2. So next, like if I simplify it, I will get x equal to ut, because 2 will cut, so ut plus half at square, and this is my second equation of motion. And now you know why it is so, because we are taking the consideration of the like acceleration, that is the change in velocity, because x equal to vt we can only use in the case when v is constant, because if the v is changing, which value of u you will put, which value of v you will put, will be never knowing it. So that's why we have to find out some v average, and geometrically and also mathematically we can find out the v average. Okay, now so this was the second equation, so I'm writing it as second equation, and this was my first equation of motion. Now coming third equation of motion. So already we have seen that if my x is known to me, so if I have to find out x and my u is known to me, a is known to me, t is known to me, I can find x. But there are some cases where, and also here you have seen there is no x, only u, v and a is there. But there are some cases when t is not provided, and in that case how we are going to find it? So we are going to find some equation where t is like substituted. T is substituted somehow, and we don't have to put T in order to predict the motion. So let us start with our first equation of motion, because it is the simplest one. So my V is equal to U plus AT. So the first you have to remember it, because I have to square it both sides. So U square plus A square T square. Now you can ask me, sir, why you are squaring it? Because I have something here that is in square, and I am feeling like that I can substitute this with that. So that's why I have squared in both sides. But with this, some more term will come, that will be my 2U, A and T. Now you can clearly see there is a correlation. Here also T and T square is there, here also T and T square is there. So let me simplify and see what is happening. So you can see here that if we take this U I am keeping as usual, and from here if I take 2 common and 1A common, so 2A I am taking common, so here I will be having half AT square plus UT, and surprisingly this and this are the same thing. So instead of this whole thing, I can write here V square equal to U square plus 2AX, right? And this is my third equation of motion. So this is my third equation of motion. So these are basically 3 equations of motions that we are going to deal with whenever we have some numericals to do. So basically the first one is this one, the second one is this one, and the third one is this one. So basically whatever we will be we will feel to find, we can do accordingly using these parameters and the equations. Now one more thing is there, and this thing is pretty interesting and also a little bit confusing maybe. Let's say I have dropped one apple from some height, okay, and I have created all the sections accordingly, like, okay, so let's say we know that already that gravity is a force that always attracts things towards earth. That means whenever we are throwing or dropping something from up, the more it goes down, the speed of that object always increases. So because of gravitational acceleration that we call as G, we can easily say that the velocity of objects increases when they are going down or when they are falling down. The value of G is nearly 10 meter per second square. But if you talk about more general value, and whatever we are using is 9.8 meter per second square. Okay, now because of the G, and as you can see that G is having a constant value, so my graph for velocity versus T will be always linear. Now you can see one thing very clearly. For the first, if you want to calculate the distance cover, you can see for the first one, let's say I am dividing the whole dropping down in some section of time. Let's say the first one is for 1 second, this is also 1 second, this is also 1 second, this is also 1 second. So all are divided into equal parts, and that is 1 second. 1 second, 1 second, 1 second, 1 second. You can see in the first 1 second the displacement is only this much. In the next 1 second the displacement is this much. In the further 1 second the displacement is this much. So you can see that the area is increasing as we are going with time, and the last one is the biggest one, that is this one. So one thing is clear, that more it is going down in the same interval of time, the displacement covered is increasing slowly. So let's say in the first 1 second it has dropped till this much, the next 1 second it has dropped till this much, and the last one is the biggest one. Let's say the first one is this much, the second is that much, third is this much, fourth is this much, and so on it is going on. So this is t equal to 1 second, this is t equal to 2 seconds. I'm not talking about time interval, I'm talking about the time, t equal to 3 seconds. So interval is 1, that is 2 minus 1, that is delta t is 1, 3 minus 2 delta t is 1, but I'm talking about time. So this is 4 seconds. Okay, so and this is t equal to 0. So when the ball or apple is going down, the distance covered is getting bigger and bigger. So let's say this is my x1, this is x2, this is x3, this is x4, and so on. Now I know with these formulas I can find out the distance very easily. See, with time I know the initial velocity. Let's say I am dropping it from rest, that means I'm just holding in my hand and I'm just dropping it. So the velocity it has started with is 0, that means my u is 0 in this case, initial velocity is 0. But so I know already u I know, a I know because a is nothing but your g in this case, which is 10 or this whatever you can use. Like most of the time we will be using this value, okay, but like for international boards and all those cases we are going to use 10. Now so already we know a also, so in that case we know u, we know our a, and we know also t, so we can easily find out x. Now if I want to find what will be my x, what will be my total distance till the time t3, what I have to do, I have to just use this formula to find out easily. If I put t equal to 3 seconds and I put a equal to g, u equal to 0, easily I can calculate x. But if I say what is x3, that means in third second how much, like from t equal to 2 seconds to 3 equal to 3 seconds, how much is the distance covered. So in that case what we have to do, in that case what we have to do, we have to first take out till t3 time what is our total displacement, also we have to find till t2 time what is our displacement, and then we have to subtract it. Whenever we will be subtracting it, we will be getting this extra x3. So whenever we are going to find out for some definite time, in the third second how much it has covered, or in the fourth second how much it has covered, in this case what you have to do, you have to calculate for t equal to, let's say we have to find out for fourth second how much we are going to get. So in that case we have to do subtraction, we have to find out for t equal to 5, and then we have to do in fourth second, let's say, so we have to do what is the distance covered in t equal to 4 minus what is the distance covered into t equal to 3 seconds. So basically there is a general formula for that. Let's say I want to find out x for third second or like nth second. So t nth time I have to find out the like displacement. So what I have to do, so t equal to nth minus x t equal to n minus 1. That means the before one. And then I have to put that formula on the ut plus half t square, that one. So basically I am writing u. So t, instead of t I am writing right now n, because the first one is tn. So un, and then t minus 1 I can say, no, or let's say this is t and this is t minus 1. That will be easier. So it will be ut plus half a t square minus u t minus 1 plus half a t minus 1 square. So if I just calculate this, I will be getting ut plus half a t square minus ut minus u plus, this will be half a t square. I am splitting directly, okay, you can do it in your copy to check. Okay. This will be 2t minus 2t, so that will be minus 2 will go away, so at, and this will be minus a by 2. And you can see that there is a minus here also. So if you just take out this given, so this will be ut plus u minus half at square plus at plus a by 2. So basically you can see that this term is gone, this term is gone, and we are left with this much. So basically in the next page I will be having u plus at and a by 2 plus a by 2, right? So if I take common, 2 I am taking common and a I am taking common. So not 2, a by 2 I am taking common. So I can write this as 2t plus 1. So what formula we have got here is a surprising formula, and that is my, you please check once everything is fine or not. Maybe the last one minus is there. Oh my god, I have done one mistake. Okay, this will be plus because 1 square and plus, and then it will be minus finally. I was thinking, okay, so basically whatever we have got here is a general formula, that is my x for nth time or tth time, you can say, for t equal to tth time. If you have this, if you want to find out, it will be u plus a by 2 2t minus 1. So this is basically general formula, but always you can do one thing for simplification. You can directly find out, let's say you have to find out the displacement at t equal to third time, not till t equal to 3 seconds. I'm talking about the third time. Then what you have to do, you have to find out x3, you have to find out x2, and then you have to just subtract it. And I have done the same thing here, and this is the general formula for that. So these are the chapters, these are the topics in that chapter called kinematics, and these, with using these tools, we are going to find out our some uh, basic things for the further chapters and new formulas. Also, all the numericals will be done using these formulas. This one is very important, the V average, and don't use this formula. You better use this formula, because this formula you can use everywhere, whereas that formula you cannot use everywhere. So this formula you can use everywhere, so use this formula only. But that formula is only valid when the T1 and T2 is same, that is the distance travel in first sector and the distance travel in second sector, the time taken is same. In that case, when the time taken is same, in that case only this formula is valid. Okay, and this is it. And the next topic we will be doing is vector, and because without vector we cannot go into the motion in 2 dimension and 3 dimension. But before that we have to solve some questions, some numericals, because without numericals, why we are learning this formula? These formulas are barely nothing but some alphabets, some equation of some alphabets. So we are basically going to use these formulas to find out some real life problems, and I will give you one worksheet for that concern, and let us try and see what is going to be happen. Okay, so bye bye. This is the class for today, and look for your assignment and try to do the assignment.